Here we go. Okay, so we're looking at a few different equations today than your what you normally see. So this, when you see, let me change my marker out. I want a thinner one. There we go. Okay, when we see this, x minus 5 to the third power, x minus 3 to the second power. 5 is a root, and 3 is a root. Okay? The degree of this, you take the two powers and you add them up. So what's the degree of this polynomial? 5. 3 plus 2 is 5. The leftmost zero, what's further left, a 5 or a 3? A 3 is. 3 is further left. And its multiplicity is its power. It has a multiplicity of 2. Now, when it's an even power, even, it bounces on the axis. Odd, it crosses the axis. Okay, and they say does not cross. I call it bounce because it hits it and goes back up. Okay, so since it's an even power, it bounces or does not cross the x-axis. The rightmost zero is 5. What is its multiplicity up here? 3, and it crosses the x-axis. So looking at the graph, do you want it to end up or end down? Is it a first term coefficient that's positive or negative?
It's gonna end up starting down now. It's odd.
It's going to finish where? Up or down?
Up.
Finish up. Okay, it's going to finish up because there's no negative coefficient out front. Okay, there's nothing negative out front. These x's are both positive, so it'll be positive, so it'll finish ending up. So it's not these two. So it's going to bounce at 3 and cross at 5. Well, this is kind of hard to see what's going on here, but yeah, I don't think it's this one. I don't think they mean this one, so I think they mean this one. Okay? All right. Find the zeros of this function. To find this, we should set this equal to 0. The first thing we should do is factor out an x. If we factor out an x, what are we left with? X squared minus 2x minus 8. Now we have to remember our factoring rules. Split up the x's, x and x. When the last sign is negative, the two in here are the same or opposite? Opposite. There's 1 plus and 1 minus. What are the factors of negative 8? Well, they're 1 and 8, 2 and 4. They have to be 2 apart and they have to add up to a negative 2. So the 4 is a negative, the 2 is a positive. So 2 goes here, 4 goes here. Okay? A little bit of a reminder of Algebra 2 how to factor. So what's the root for this x? If these all equal 0, x equals 0. If x plus 2 equals 0, x equals negative 2. If x minus 4 equals 0, x equals 4. The three roots are 0, negative 2, and 4. Find the zeros algebraically. This is just factoring is what they're asking you to do. R and R. This is negative, so we have opposite signs, plus and minus. What are factors of 54? Well, they're 1 and 54, 2 and 27. 3 goes in here 18 times. 4 doesn't go in there, 5 doesn't go in there, 6 goes in there 9 times, and hey, there we are. Signs are opposite. The bigger one is positive, the smaller one is negative. Well, these two add up to a positive 3, right? A negative 6 and a positive 9. Okay? So, what are the roots? Well, r must equal the opposite of this, negative 9, and the opposite of this, a positive 6. Okay, now when you have the zeros already, what's the function that it belongs to? What are the coefficients of all the variables? Well, how do we find that? Well, we can simply multiply them. X plus 2 times x minus 3 times x plus 7. Let's multiply these last two first. So it's x plus 2 times x is x squared. Outers is plus 7x. Inners is minus 3x. 7 minus 3 is 4x. Negative 3 times 7 is negative 21. So now here we have to double distribute. Distribute the x to get x cubed plus 4x squared minus 21x. And then we get 2x squared plus 8x minus 42. So it's x cubed plus 6x squared minus 13x minus 42. Well, the only number we needed was the 6. Now, for you lazy people, you could put each of these equations into your graphing calculator and figure out where these are and do it that way, okay? Or you could do the math. X minus square root of 6, negative square root of 6 is x plus square root of 6, and x minus 2. Well, obviously, I'm going to FOIL these two together first since they're both square roots of 6. X times x is x squared. Outers is x squared root of 6. Inners is negative x squared root of 6. What do the outers and inners do? Cancel. These are what you call conjugate pairs. They're the exact same, except for one has a plus sign, one has a minus sign. Conjugate pairs. In conjugate pairs, the middle two terms always cancel. Square root of 6 times square root of 6 is 6. So x squared minus 6 gives us those two. And then we have x minus 2. So we FOIL. X cubed, outers, minus 2x squared, inners, minus 6x, plus 12. Which one does it match? Looks like it's B, right? There we are. The State Highway Patrol gathered data on speed and stopping distance. What's the scatter plot going to look like? 10, 20.9, 20, 31.5, 30, 75.2. Is it A or B? No. The higher this number is, the higher this number is. So it's going up. 10, 20.9, 20, 30. I don't know which one is exactly the right one, but you'd have to check out on your graphing calculator, I should say. I'm kind of leaning towards this one is probably the one. Okay? So, let's do this on a graphing calculator as long as come back. Come back. There we go. Graphing calculator. Boom. Okay. All right. How do we do this on a graphing calculator? Because some of you probably don't remember. Stat. Edit. Go up. Do not push delete. Up. Clear. Down. Over. Up. Clear. Down. If you push delete, you'll delete one of your lists, and then we'll have to reset your calculator to regain your list again. So don't do that. All right. So in the X, we're going to go 10, 20, 30, 40, 40, Mr. Bierschbach, and 50. Over here, 20.9, 31.5. Oh, Mr. Bierschbach. 20.9, enter. 31.5, enter. 75.2, enter. 119.5, enter. 170.5, enter. Okay. So I want to get a graph out of these. How do I get a graph? Well, I'm going to do this. I'm going to go stat. And then I'm going to go over to calculate. And then what I want is I want a quadratic regression model in a little bit. So I'm going to go down to number 5. Quadratic regression. I'm going to hit enter. List 1, list 2. But now where you hit this store regression equation, we're going to put that regression equation into y1. So how do we do that? Well, we go vars over to y vars, function, enter, y1, enter. What it'll do is it'll take that regression equation that it's going to make and put it into your y1. Now you're going to go calculate. Okay? And you can like plug the numbers in, or if we go to y equals once, there's our regression equation. 0.058 something 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 plus x squared plus 0.383 something 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 plus 0.806. So over here, it would be choice C. Whoops. So what does it look like as a graph? Well, let me go back to the graphing calculator. Push graph. Uh-oh. We don't see much, do we? Okay. We can go with what they have here for a window. 0 and 60 for our x's, and 0 and 200 for our y's. And it looks like that. If we want, we can turn our stat plots on and actually have the squares. So it was choice D. D was the correct choice up there. Down here, A would be the correct choice. At 26 miles per hour, we're supposed to guess the stopping distance. Well, our graphing calculator can help us with that. We go trace, but we don't want to be on the dots. We want to be on the line. To be on the line, press your up arrow, and now you're on the line. And then you're going to type in 26 to get an x value of 26. What's your stopping distance at 26? Well, it's 57.33 feet. So the graphing calculator with its regression equation will help you find things in between. 400 feet. How long will it take? How fast is it going if it's 400 feet? Well, we're going to trace on this line and go over till we get, or go up until we get to 400. Now, I'm going to go till I get to 400, but pretty soon I'm going to run into an issue. What's that issue? It's going to stop. Oh no, what am I going to do? Well, I got to change my window. So I'm going to change this to like 150 for my X max and 500 for my Y max. Then if I graph it, I can figure out what this is. Now, here's the trick. To get to 400 really quick, set Y2 equal to 400. 400's right there. Can you see where 400 is? And then I'm going to go second trace, and I want to get my intersection between those two. So I'm going to hit enter, enter, enter. My intersection is at 78.87. So if they're going 78.87 miles per hour, that should be how long it takes for them to stop. Or it should take them about 400 feet to stop. Okay? So our last question is a good one where we use the regression stuff on our calculator. So one more time through there. To put the numbers in, we went edit and we put the numbers in. Then we went we went stat and then over to calc and then down to number 5, the quadratic regression. And then we went down to store our equation. Where do we store it? Well, we store it into y1. Well, how do we get that? We go vars, y vars, enter, enter, enter. See how it's y1 now. And when we calculate that, and we go to y equals our equations in there, and so on. Okay, we good? Okay, so there are, what problem number was that? That's like problem number 6. So there are 6 problems for you to do before lunch. After lunch, we're going to get into synthetic division and talk about a little bit about long division maybe too. So that's after lunch, and then I'm leaving for cross country. But the cross country runners don't get to leave quite so soon.